Hi friends, in this lesson we will be doing something like this. Okay, this is a piled foundation. Okay, this piled foundation is carrying a load of 350 kilonewton. Okay, and so I have to use a single column. Okay, then I apply the load on the column so I can design the pile cap. Okay, so this is what we will be looking at, how to apply a load on a single columns. Okay, so if you are new to this channel, subscribe as you support the channel, like the video and share it. Stay tuned for more advanced lesson of this kind. Okay, so let's start. I will click on the new and I will add one. Okay, and click OK. BS8110 I will import. Okay, so I will pick my grid line. In the direction A, okay, I will click and give it a distance. Can hold your control key to straighten the grids. Okay, alright, so I want to click on the columns. Okay, I want to use column size of 450 by 450 of thickness. Okay, that is the section of my column. I closed. Okay, so after which I will save the project. Alright, so the next thing I will do, I will set my material. I supposed to apply the load now, but if I use this structural element in 3D that you are seeing, I will have to reduce the height of the structure by going to building and then click on edit. In the edit, I will reduce the height to 2500. Okay, and I will click OK. So I want to apply another load of 350 kilonewton to this columns so as to be able to design the foundation. Now the foundation is going to be pile. Okay, so you can see the property of this column. Okay, so if I align it and then right click, I want to use this column node load. Okay, now if I click it and I say applied, it's a low cases and combination not defined yet. Okay, I'll click OK. So I could not apply the nodal load because the load case have not been set. So I want to set the load cases. Now click on analysis, then I will click on 3D building analysis. Okay, so after which I will click on this parameter. These are the codes of practice I'm using. I want to change the soil bearing capacity to 80. Okay, and the title you can also change it, but this work is made by soft reason. Okay, after which I will go to the loading combination tab. In the loading combination I will generate my loadings. Okay, and click on OK. I will also edit my material. In this case it is only column and the foundation I am designing, so I'm going to edit the rebar diameter of my columns, okay, to be y16, okay, and y20 25 will also be there. Okay, I'll also come to my foundation. Okay, and then I will use 12 and 16 for the foundation. I will also select 25 and 20. Okay, then I'll click OK. I go back to default material, my links. I will use 10 and 8. Okay, I click on OK, and then I closed. Okay, so now I want to add the another load of 350 kilonewton to this column. Okay, so I will select the column, right click, and then I will click on column node load, then I click on applied. Now in this dialog we are going to apply the load on the G, okay, negative G in the FY. Alright, so I will double click on this point and I will use minus 350 kilonewton. This load is acting directly on the column. Okay, so I will click OK. So as soon as I click OK, if you check the column property now, you will notice that you will be having another load minus 350 kilonewton. Okay, so I want to save the project. After saving the project, I will navigate to the plan view. After which I will run analysis of this element. Okay, I will click on analysis 3D building. Okay, I will go directly to the analysis tab. Make sure this your rigid zone is none. Okay, then go to analysis. I want to design the column. Okay, I want to analyze and design the column. Okay, and so I will click on start. So building analysis completed successfully. I will click on OK and I will close. Okay, so the next thing I will do, I want to check if this column is actually designed. Okay, so I will click on column here, right click and column section design and detailing. You will notice that the column has not been designed. Okay, that's why you are seeing this red mark here under design. Okay, so we want to design the column using bash design, so I will click on design. Okay, you notice that the column did not also design. Okay, so what are going to do, we use interactive design. Okay, so we click on interactive design. So let us really know what is causing this column not to design. If you check this point, they say column still not calculated, meaning it is not designed. Okay, so let us do interactive design. You click on this interactive design. Okay, you will see something here. They said still bar size limit exceeded, numbers of bar must be increased. Okay, this is what they said. So we click on OK. So we need to increase the number of bar, so we click on reset bar, then we update. Okay, and we click on design. Okay, so look at the warning we have in here. They said still bar cannot be selected, section size is insufficient. Okay, so we will OK it and increase the section of the column. Okay, we will be using 500 by 500, and then we update. Okay, after which we click on interactive design. As this is the warning, still bar cannot be selected, section size is insufficient. Okay, so what we need to do now is you click on OK again. We increase the section to 600 by 600. We update. Okay, and then you do the interactive design again. Alright, you will notice that this has passed. Okay, we have critical load combination 1 still 32 y 25. Okay, with the area 15707.96 meter square. Okay, and so this column has been designed now. Okay, so click on OK. If we check here, there's a required area is this, supplied area is this. Okay, so the column has been designed. So you click on OK. You can see here has changed to good. Okay, so after which we will now proceed to the design of the pile foundations. I will close this. Okay, so I will click on this, right click, okay, I will navigate to the story 0. I will navigate to the story 0. Then I'll click on this column, then I will right click, then I'll select 22042.5. Okay, alright, so the program has designed the pile foundation for me. Okay, it has designed it successfully. You can see the spanning fairings, the spanning fairing maximum, the cantilever pile capacity check. Alright, bending design result. You can see shear capacity, all the check has been carried out successfully. Okay, you can check your material here. Okay, the material we use in the design, you can see the concrete type is normal weight, not lightweight. Okay, and so if you come to design check, these are the necessary design check. Okay, everything has been checked, everything has been passed. Okay, come to report and drawing. If we check the rebar, okay, you also come to result. Shear check, bending design in this x directions, shear design in x direction succeeded. Okay, every other things has been, and finally design completed successfully. You see. Okay, so the next thing you need to do, you can't just click on OK to insert the pile. So this is the pile design. Okay, so let us save the project. I want to navigate to the 3D. Alright, so this is what you will have. Okay, this is your pile foundation design in respect to the load 350 kilonewton. Okay, so if I want to further do any editing on this, I will highlight one of the pile, right click and select property. Alright, in this property it is where you will see the length of the pile, which is 5 meters into the earth, but this length can be increased. Okay, this length can be increased. If you change this length, let me say 15,000 into the earth, let's see what happens. Okay, I click on the OK. Alright, so what I will do, it doesn't work. What I will do is I will highlight all the pie just like this. Okay, and now we right click and click on property. I will make it this place 15 meter and I will click OK. I will click OK. So this is it. Okay, I'm now having a pie of length 50 meter into the 8. Okay, so this is how pie foundation in respect to a specific load is being designed. Okay, using Protastructure. So we want to proceed to checking the pie foundation. We want to print the report. You click on this point. It is preparing the report, as you can see. Okay, so this is the report. This is part 14 design. Okay, this is the section of this pie. These are the unnecessary information. Okay, in material used, analysis, so you can just print this. Okay, design check, summary, so you can just print this and then you will add it to your report. Okay, so you will click on this to print it. Okay, you click on this and you click on the document and save it. So this is it. You click on closed and you close this. Okay, so the next thing I will want us to do is let us get the complete drawing of this. Okay, so by then, before then, we have to save the project. Okay, so after saving the project, you go to ROC design. In the ROC design drop down menu, you click on Prota details. This will take us to the Prota detail where we will be able to get the design drawings of this column and as well the pie cap and the pie itself. Okay, Alright, so we will be having something of this kind. So I will click on auto generate detail. Click on draw, and I will click anywhere on the environment to start the drawing. The drawing has been done successfully. Okay, so this is your drawing. It's just like the top view of the pie and the columns. Okay, so this is the column design, elevation of the column. This one is the pie and the section. Okay, this is the bar bending schedule for the pie. Okay, you can see the bar bending schedule for the pie. And so if you want to export it to AutoCAD for further editing, you just click on this, you right click and then click on export. Okay, so this brings us to the end of the lesson. Okay, if you have not subscribed, kindly subscribe and stay tuned for more advanced lesson on this channel. Okay, you can like the video as well. So this is where we will stop. Bye for now.